Hello, it's good to have you here. I love the tutor. This question is on page 166 of Functional Mathematics for Senior Secondary Schools, Book 2 by T.M. Asiru et al. The question says in figure 10.28, P, Q, and R are points on a circle with center O. If angle OPQ is equal to 36 degrees, find angle PRQ. Now, angle PRQ that we've been told to find is this angle located at R, PRQ. Okay, and now this angle PRQ is subtended by by this chord, this line from P to Q, this line from P to Q. Okay, and this chord PQ also subtends another angle at the center of this circle, which is this POQ located at O. And we have a circle theorem that states that any angle subtended by a chord at the center of a circle is twice the angle the same chord subtends at any other point on the circumference. So we have that angle. So whatever you have as POR, PRQ, this angle will be half of what you will have here. Okay, so we have that angle PRQ is equal to half of angle POQ. POQ is the angle at the center of the circle. So the reason is that the angle an angle subtended at the circumference of a circle, at the circumference of a circle by a chord or an arc, is half the angle it subtends at the center of the circle. At the center of the circle. So, and that is what we have up here. So now we have that POQ. Okay, we have that OP, line OP, which is this line from P. Okay, this line from O to P, is equal to line OQ. From O to Q, down to Q, this line from O to Q is equal to line OQ because they are the radii, and the radius is a constant distance from the center of the circle to any point on the circumference of the circle. So the radius is always the same. Alright, so now since OP is equal to OQ, it implies that now this implies that triangle OPQ is isosceles. An isosceles triangle is a triangle with two equal sides. So now this also implies that now from the isosceles angle OPQ, we have that angle OPQ is equal to angle OPQ is equal to angle OQP. Reason is that they are base angles of an isosceles triangle. Okay, so OPQ is already given to us. As 36 degrees. OPQ is 36 degrees. It was given. So therefore, since OPQ is equal to angle OQP, it implies that angle OQP is also 36 degrees. So now that we have two known angles in triangle OPQ, that means we can find in triangle OPQ, that means we can find angle POQ. Okay, so we have from triangle OPQ, we have two known angles, which are OPQ and OQP, which are, so we have, sorry, this is supposed to be so now we have 36 degrees plus the two base angle 36 degrees plus angle POQ, which is equal to 180 degrees. Sum of angles in a triangle. So now, okay, so we have 36 degrees plus 36 degrees will give us 72 degrees plus angle POQ, which is equal to 180 degrees. So we have that angle POQ is equal to 180 degrees minus 72 degrees, which implies that angle POQ is equal to 180 degrees minus 72 degrees will give us 108 degrees. Now remember what we stated, that angle PRQ, which we've been told to find, is equal to half of angle POQ, which is the angle subtended at the center of the circle. So we've gotten our POQ to be 180 degrees. So this implies that angle PRQ is equal to one half of angle POQ is 108 degrees. So if 2 divides 108, you will have 54. Okay, 54 degrees. So this implies that angle PRQ is equal to 54 degrees.